My dear students, other viewers and listeners, I, Professor Manohar Lal, School of Computer and Information Sciences, welcome you to this fourth lecture on the programming language Lisp. We know that language Lisp is an artificial intelligence language from our previous lectures. In the previous lectures, we also mentioned a number of characteristics of the language Lisp. In addition, we defined the various data structures and the data types which are available in the language Lisp. Further, we discussed a number of operations and functions which are numeric in nature and available in the language Lisp. Today we will continue with our previous lecture, and today we will be discussing a number of non-numeric operations which are available in the language Lisp. Friends, I have already mentioned that Lisp language is mainly in non-numeric, that is symbolic programming language, where the symbolic operations dominate the numeric operations. So friends, with this introduction, in continuation of the previous lectures, let us now look at the various symbolic operations which are available in the language Lisp. Please look at the slide. The Lisp manipulation functions are char, coulter, cons, etc. We'll discuss one by one. The char function takes an argument which is a list-quoted list, and it returns the first element of the list. For example, on the slide we have char quote the list DBC. Now the first element of this list is D, and therefore the char returns the element D, which is the first element of the list, which is an argument for char function. However, we must be very careful that the first element need not be an atom or a number. It may be list also, and in that case the whole list is returned if the first element happens to be a list, as you can see from the second example, char quote, and there is a list. However, the list has the first element as the list DB, and therefore in this particular case not the element D but the list DB is returned. I again draw your attention to this fact that char returns the first element. The first element may be an atom, it may be a number, it may be a symbol, but it may be a list also, and in case the first element of the given list which is given as an argument to the function char, then the list is returned and not the first element of the list which is the first element of the given list. Again we take a look, we have a look at the third example. We can apply the chars in a sequence, that is whatever is the char inside, whatever is written by that, then the second char operates on that. So friends, first of all we look the inside part, that is char quoted list. And as we see from example second, the list DB is returned. Now the second char, which is the leftmost char, operates on this second list which is DB, and hence it returns D. So you can apply a number of chars to a given list provided each time the return is a list. In this particular case, the rightmost char returns DB list, and then the leftmost char operates on the list DB, and the first element of that is an atom which is D. So you can apply a number of chars, but the first char which is applied to the list is the innermost or the rightmost, and then it goes on towards the left and the application of various chars. I hope that it clarifies how the chars are applied. We take another example from the next slide, char, and there is a list, and in this list there are 5 elements, each of which is an atom. Lisp is an AI language, and here Lisp word LISP is returned because it is the first element of the given list, and therefore list is returned. Again, not only the list may be given explicitly, it may be given implicitly also. That is, in this particular case, first of all, through the setq operation, a list may be associated with a symbol. And once it is associated with the symbol, then the symbol may be used instead of the list. So, in order to find out its application, let us look at the slide. The slide says that first of all, setq x quoted list ABC. Through this operation, what we are doing, that now in henceforth the symbol x will be representing the list ABC. And hence, whenever the list ABC is to be used, instead of that we can use the symbol X also. And therefore we can say, instead of car of the list ABC, we can also say car X. And because X has been associated by previous operation of setq x, and therefore now X represents the list ABC, and its first element A is returned. I hope this is very clear, that instead of a given list, you can associate a symbol with the list, and that symbol now represents the list. Next. Now the second most important operation is CUDR. The first operation, car, has to be applied only to a list. Here we must remember that both car and CUDR, which I am going to explain in a while, both can have its arguments only lists. If we have a symbol and which has not been associated early with a list, then an error will be returned. Once again I repeat, because the point is very important, the functions car, CUDR, and further we'll discuss cons, etc. They will have one of their arguments as list. I have already mentioned that a symbol may be associated with a list. However, if a symbol has not been associated with a list, and then we talk of car of that symbol or CUDR of that symbol, then it will return error. So friends, with this introduction, let us now discuss the second function, which is symbol operating function, namely CUDR. Let us have a look for its explanation on the slide. Here CUDR, as I mentioned, again has its argument as a quoted list. But what it does, that whatever car returned, it drops that element, and whatever is left of the list after dropping the first element of the list is returned. That is, CUDR always returns a list, and it takes its argument also as a list. So in this particular case, CUDR quoted list DBC. Now the quoted list DBC has three elements, namely D, B, and C. Out of this given list, the first element is dropped, and the rest of the two elements constitute a list which is returned. So in this particular case, CUDR returns the list BC. So CUDR is a symbol list operating function which takes the argument as a list and returns also a list. Now further clarification. CUDR of another list, but the difference between the first list and this list is that now DB itself is given as a list which is an element in the given list, and hence, as in the case of car, the first element, which is a list DB, is dropped, and we are left with the list C. So we have to be very careful. The first element of the given list may be a symbol, may be a number, may be a list, but whatever it is, the whole of it is taken as the first element, and in the case of car it is returned as such, and in the case of CUDR it is dropped. So friends, CUDR of the quoted list, in which there are two elements. The first element is the list DB, and the second element is C, and the first element is to be dropped in the CUDR operation. Therefore we will be left with the list C. Third example, CUDA Lisp is an AI language. Now the list which is given as an operand to the function CUDA has 5 symbols, 5 elements. The first element is to be dropped for the purpose of taking CUDA, therefore Lisp is dropped. And whatever is left within the list is returned as a list. So CUDA quoted list, Lisp is an AI language, returns the list is an AI language. I hope the 2 functions which are very important functions, which are list operating, list manipulating functions, must be very clear, because as I mentioned earlier also, that Lisp is mainly symbol or list operating language, because most of our ideas in everyday life are expressed in terms of symbols, expressions, etc., symbolic expressions, etc., and not as numbers. And Lisp, this is why is very important when we are doing more complex tasks as compared to just numerical tasks. So friends, with this I'll give you further explanation of list. Now in this particular case we are associating the symbol X with the list ABC. So what will be the CUDA of X? CUDA of X will be BC. But we must note that CUDA quoted X. When we are saying CUDA X, then X has already been associated with the list ABC, and therefore actually we are taking the CUDA of not X as such, but the associated list which is ABC, and therefore we get the right answer. However, when we are giving a command, an instruction like CUDA quoted X, now quoted X evaluates to the symbol X and not to the list ABC. There is a difference between CUDA X and CUDA quoted X. CUDA quoted X, in this particular case quoted X is evaluated, and quoted X evaluates to X and not the list ABC, and therefore it will return an error, because we just mentioned that CUDA requires as its argument a list. It cannot be a symbol. Similarly, car requires as its argument a list and not a symbol. And in both of these cases, if the argument evaluates, I underline the word evaluates, if the evaluation leads to a symbol, then the car and CUDA will give the error. Friends, car and CUDA can be used to retrieve not just the first element as it is done by car. We know that the car function is used to return the first element. The first element may be a number, maybe a symbol, maybe a list. However, in many of the applications we may not be interested in the first element. We may be interested in the nth element, say 4th element. Then what is the mechanism of retrieving the 4th element? So please, for this purpose, look at the slide. The slide says that if you are to recover the 4th element, then you use 3 CUDAs and finally a car. You can see how it operates, how it will return the 4th element. You can see the first CUDA, when it is applied to the list 1, 2, 3, 4, 5, 6, then what it will do? The first CUDA will eliminate 1 from the list and will be left with the list 2, 3, 4, 5, 6. And then the next CUDA is applied, and the second CUDA, when applied to the list, will return 3, 4, 5, 6 as a list. When the third CUDA is applied, then we will be getting a list 4, 5, 6. And finally the car returns the first element of the last list, that is 4, 5, 6. And hence 4 will be returned. So in general, if we are required to find out the nth element of a list, then in that case what we should do? We should use first car and on the left, and then n-1 CUDAs, and finally the given list as an argument, quoted list as an argument. Then application is always in the reverse order, that is the CUDAs will be applied first. And because there are n-1 CUDAs, therefore they will be deleting one by one from the left of the list n-1 elements. And now whatever is the list returned by the final coder will be the nth element, will be the first element of the new list, and the car will return that. So it is very simple to understand that how the nth element can be retrieved from a given list. That is, you apply n-1 coders and finally one car. That is, car must be written on the leftmost, and then n-1 coders should be written, and finally the quoted list must be returned, from which we are interested in finding out the nth element. I hope this is clear to everyone. Now, because we can see that writing cars, CDR, once again I may not have mentioned it clear, though it is written as CDR, but it is read as coder. CDR is read as coder. So with this clarification, friends, now writing a number of cars followed by a number of CDRs, it is a bit cumbersome, and one of the purposes of language is to facilitate the notation, and therefore in order to facilitate this cumbersome expression, we can drop the R's and C's, and only A's and D's may be written except the first one. So what can the notation may become? But first of all, we will have an example how to get the address from a particular list. So in this particular case it is very simple, because the address is given at the fourth element, and therefore 3 coders followed by a car is applied and we get K76. But I was telling you the simplification. Please look at the slides. That is, if you have an expression car followed by coder followed by car followed by coder, and a list is given to you. In this particular case, the notation can be simplified. That is, you may keep the first C, only one C, and for each car you write an A, and for each coder you write D, and go on like this one, and finally you just write the R. I again explain, if you have a sequence of cars and coders which are to be applied to a given list, then instead of writing the full CAR or full CDR, there is a mechanism by which the notation can be shortened, and the notation is something like this, that first you write a C, for each car you write A, for each coder you write D, and when all the cars and coders are completed, then you write an R. So the given expression, there are 2 cars, so for the 2 cars there are 2 A's following C, then there is a coder, a D is there, then a car is there, so A is there, then there are 2 coders, so 2 D's are there. And when all the cars and coders are exhausted, then we will be writing R. So this facilitates, however it can be written in a number of ways. The another way is that you may write for the first 2, car followed by car as CAAR. Then for the other you may again use a shorthand notation. So there are various combinations in which written, but the simple rule is that whenever you are writing one part, so you write a C followed by an A for a car and a D for a coder, and finally an R. I hope this clarifies the simplification of the notation of cars and coders. Friends, I mentioned there were 2 list operating functions which we discussed just now. One is car, the other is coder. The main function, the main role of these 2 functions was to extract elements from a list. But in the beginning, when the data is given, the lists have to be built up. When the lists are built up, then and only then we can extract elements from the given lists. So how to build up the lists? So cons is one of the operations which is used to build up lists. For this purpose we have a look at the slides. Here the cons takes 2 arguments. One is any S expression. Any S expression may be, it may be atom, it may be a number, it may be a string, it may be any S expression. Cons takes 2 arguments. The first may be any S expression, it may be a number, it may be a symbol, it may be a list. However, the second element must be a list, quoted list. Once cons In this particular case, quoted star, quoted the list 47 is given to us. What cons does? Cons in this particular case inserts the first argument, in this particular case star, as the first element of the second list. That is, another element is added to the given list, which is second argument of cons. So in this particular case, cons quoted star quoted 47 list. Then if you apply this function, or Lisp environment executes this command, then we will be getting a new list in which the first element star has been added as the first element, and 4 and 7 are shifted to the right. So you can see the output of cons is a new list in which the first argument becomes the first element of the given list. Similarly, however, again we have to be very careful that the S expression need not be just a symbol. It may be any S expression, it may be a number, it may be a symbol, it may be a list also. So second example says the cons quoted list AB and quoted list BC. Now the first argument in this particular case is quoted AB list, and its evaluation removes the quote from it, that is, its evaluation leads us to a list AB, and this list AB is to become the first argument of the first element of the second list. So what is returned is a new list in which the list AB becomes the first element, and the earlier elements are shifted to the right. The earlier two elements in the list, which is second argument, are A, B, C, and therefore the returned list is a list in which the first element is the list AB, the second element is the B, and the third element is C. Friends, we know that nil is having double rule. Nil may be used as a list with no element at all, and nil may be also used as a false. So sometimes when we are beginning an operation of building a list, initially we will have a nil list. Now what will be the consequence of applying cons in which the second element is a nil list? Please, for this purpose, look at the slide. Cons quoted a nil. However, nil evaluates to the nil list, and because nil list doesn't have any element, therefore the first argument on evaluation becomes A, which is made as the first element of the second list, and because the second list does not have any element, therefore the written list is only a single element list, that is the list A. I hope this clarifies the cons operation. Then, as I mentioned, earlier we were, particularly the car and CUDA, were operations which were used to extract information from a given list. Then we started with operations which are used to build up lists. The first list operation which is used to build up lists is cons, which we have already discussed. Then the next operation is list. How list builds. The operation list is different from the data structure list. We must be very careful. Sometimes the same name may be used for different purposes. So we already have studied the data structure list. Now the second use of list is as a operation to build up list. For this explanation of the operation list, please look at the slide. The first of all, list, what it does, it is given a number of parameters which are evaluated, and the arguments so obtained are grouped into a list in the same order as the corresponding parameters are given initially. For example, we say set q x quoted list AB, set q y quoted symbol intelligence. Now, what will be the effect of the first setQX quoted list AB? The effect of setQX quoted list AB is that the symbol X is associated with the list AB. The second instruction, setQY quoted symbol intelligence. What will be the effect of this? The effect of this is that the symbol Y is associated with the symbol intelligence. Now suppose, now we are given an instruction list quoted X, Y, X, quoted list, quoted symbol knowledge, quoted Y. Now what list does? As I just mentioned, first of all, one by one it evaluates its arguments. And whatever are the evaluated arguments, they are grouped together into a list in the same order in which the arguments are given as arguments to the function list. So we know that quoted X evaluates to X. Please try to understand, quoted X evaluates to X, but X evaluates to the list AB. There is a difference. So we are to first of all evaluate the arguments and their values are put in order, and then whatever is obtained finally is enclosed between pair of parentheses. So quoted X evaluates to X, we write it down. Then Y is not given as quote, and because Y is not given as quote, therefore its value must be something to which it has already been associated through the setQ operation. So Y has been associated with the symbol intelligence, so Y will be evaluating to intelligence, and therefore it is the second element of the list. Third argument in the list operation is X symbol, which is not quoted. And because it is not quoted, it is expected that it must have been associated some value earlier through some setQ operation. And we know that setQX has already associated the list AB with the symbol X, and therefore the value of the third argument is the list AB. It is written in that order. And finally, the fourth argument is quoted knowledge, and any quoted S expression evaluates to whatever is obtained by removing quote, and because quoted, and hence the length will return the number 4. However, you may say the number of atoms which are present, the number of symbols which are present in this is A followed by A, followed by B, followed by C, followed by D, followed by E. That is, in this particular case we could have got 6 elements. But no, I repeatedly say that when there is a single element and all the operations will be applied on that, treating the whole list as a single element. So the length represents, or length returns, the topmost number of elements, which in this particular case happen to be 4. Sometimes as we get car. Now the car function returns the first. Sometimes we are interested in the last element.